Okay, let's jump right into this explainer. Right now, there's this massive, incredibly dangerous climate event brewing that could literally turn global weather upside down. We're talking about a phenomenon with the power to completely rewire global temperatures, rainfall, the whole shebang. It's basically a waking climate giant, and scientists are sounding the alarm that we might be on the precipice of a historically severe disruption. So to truly grasp what's happening, we need to look at the main engine of our planet's climate.
And to do that, we have to start with the Pacific Ocean. It is a staggering body of water. It holds roughly 50.1% of all the Earth's ocean water. That sheer volume is the absolute foundation of our planetary survival, acting as the primary engine that drives our global climate systems.
Because honestly, if it weren't for our oceans, and specifically the immense size of the Pacific acting like this giant planetary heat shield, Earth would literally be a lifeless, boiled egg. Our planet absorbs an incredible amount of solar radiation, right? And without this massive body of water acting as a buffer, the surface of our world would just be an uninhabitable desert.
Water has this almost magical ability to absorb heat. To put that into perspective, it takes about 4,000 times more energy to raise the temperature of water by 1 degree Celsius compared to the air. That means our oceans can soak up a monumental amount of thermal energy from the atmosphere without boiling over themselves. They are the ultimate planetary sponge for heat.
But here's the thing, we've been testing the absolute limits of that sponge. Since the Industrial Revolution, our oceans have silently absorbed over 90% of the excess thermal energy created by human activities. For over a century, the ocean has been working overtime, just quietly pulling that dangerous excess heat right out of the air we breathe.
So the crucial point here is that if the ocean hadn't stored all this extra heat by now, if all that heat had just stayed in our atmosphere, our world would be a catastrophic 36 degrees Celsius hotter today. Just think about that for a second. All life as we know it would be completely extinguished. We owe our current existence entirely to the ocean's capacity to hide this heat.
Which brings us to Section 1, Earth's massive radiator system. Let's look at how this cooling system actually operates.
Driven by the intense sun at the equator, surface water heats up and gets pushed by massive currents toward the freezing poles. But the ocean doesn't just keep that heat on the surface. It has a deep vertical circulation system. Normally, the top layer, down to about 700 meters, absorbs the heat. Modern data, however, shows that this excess thermal energy is increasingly pushing down deep into the ocean. Even the coldest, darkest depths of the Pacific, down to 2,000 meters and beyond, are now absorbing this modern warming.
Now, on to Section 2. When the wind reverses. This massive radiator relies on a very delicate balance, and right now, that engine is sputtering. See, under normal conditions, you have these powerful trade winds blowing west across the Pacific. They push warm surface water toward Asia and Australia, bringing lush tropical rains, while allowing cold water to rise along the Americas. But when an El Niño hits, this delicate system just completely breaks down. The usual trade winds suddenly weaken or even reverse. So a massive pool of warm water sloshes back eastward toward the Americas, totally upending global weather patterns. Asia gets dry, the Americas get flooded, and the whole planetary radiator is basically thrown out of whack.
And that leads us to Section 3, the overload, a Super El Niño. We aren't just facing a standard disruption right now, we're looking at an extreme, catastrophic version of this event.
It triggers a terrifying, vicious cycle. First, an unusually massive area of the ocean heats up, which causes rapid evaporation. All this excess water vapor acts as a highly potent greenhouse gas, which then traps even more heat, feeding right back into incredibly violent, non-stop storms. The heat creates the storms, and the storms trap more heat. It's a perfect storm, literally.
Section 4, the hidden fuel tank. Subsurface heat is exactly what makes this upcoming event uniquely dangerous.
Because of decades of global warming, there is a hidden fuel tank of immense heat stored right beneath the ocean's surface. Satellites and deep-sea buoys are currently watching these terrifying underwater heat bubbles, these massive reservoirs of thermal energy, creeping eastward towards South America. It's effectively a hidden payload of fuel. If these deep heat bubbles surface and release their energy into the atmosphere all at once, the climate's reaction could be incredibly violent.
Section 5, the South Asian threat. Let's zoom in on vulnerable regions to see exactly how this ocean overload threatens things on a local level. South Asia is uniquely vulnerable here. Because Indian and Sri Lankan agriculture relies almost entirely on the strict stability of annual monsoons, even slight wind reversals thousands of miles away in the Pacific threaten to delay rains or disrupt them entirely. We're talking severe, prolonged heat waves, massive crop failures, terrifying water scarcity, and ultimately skyrocketing food prices impacting millions upon millions of people. A disruption in the ocean translates directly to a crisis on the dinner plate.
Section 6. A terrifying new era. We really have to ask ourselves, are we prepared for what historical precedents are telling us about this current threat?
The timeline here paints a really grim picture. Back in 1877, a massive climate event caused global devastation. Fast forward to 1997 and 98, and a Super El Niño caused billions of dollars in global damages. But jumping to the present day, this is why researchers are deeply alarmed right now. The incredible amounts of subsurface heat we're measuring today are rapidly matching, or in some regions even exceeding, the levels that preceded that devastating 1997 event. The ocean is primed with even more energy than it was during one of the most destructive climate events in modern history.
And the most unsettling takeaway from the latest scientific modeling isn't just the sheer amount of heat, it's the speed. Our warming planet's oceans and atmosphere are reacting to these changes far faster than they ever have in modern human history. What used to take decades of slow buildup is now shifting in real time. The system is highly sensitive, and the acceleration is just totally unprecedented.
Which leaves us with this final, chilling question, as this waking climate giant arrives at our shores. With a hypercharged ocean, a rapidly shifting atmosphere, and a hidden fuel tank of heat waiting to surface. Are we entering an era of frequent, unpredictable Super El Niños? An era where extreme is the new normal? Because no matter where you live, the Pacific Ocean's changing tides will eventually reach your doorstep. Something to think about.